Alright, you kangaroos, let's get jumping. We have a pretty complicated proof here. You're told the triangle is congruent and want to prove a triangle is congruent. Of course, they're not the same triangle. So this one's going to take a lot of careful planning and understanding of what happens when you're showing triangles are congruent or when no triangles are congruent. If this is not the first video you watch, you've seen this kind of theming played out quite a bit. If you have a triangle is congruent, that tells you information that might make the other triangles congruent or what you need to prove the triangles are congruent. Notice I've really changed my diagram here. And by change my diagram, I just mean I took the givens and marked up my diagram to help me kind of visualize what's going on. If I know ZWV, is congruent to YXV, these are the two kind of wing triangles, if you will, to help you kind of visualize what's going on. If those are congruent, I know all the corresponding parts are, which is why it's marked the way it's marked. I did this because I want to be able to kind of really visualize what I have to help me prove the triangles in question are actually congruent. Let me kind of explain what I mean. So I have, let's change this color. Line style, those crazy little knobby things. Well, make some dots. Make it green. Save tool properties. Okay, so I want to prove that this triangle, ZWY, is congruent to its counterpart. But to do that, I have to realize I have a lot of information already. Because the first set of triangles were congruent, I know that these angles are congruent. I know that this side is congruent. I know that these sides may be able to be kind of matched. I don't have the full angle here. So I'm looking at this. I'm going to kind of pull this away. I have a lot of information already. I have an angle and I have a side. So if I'm kind of thinking about what conditions prove triangle congruency, I have to do a good job kind of picking the right condition, so to speak. I have a side, I have an angle, so I'm probably not going to use side, side, side. Why embed all this extra information that I don't have to, if that makes sense? I'm looking at side, angle, side. That's a possibility. I have this side, I have this angle. This is a side in question. Do I actually know this in both triangles? Well, let's pull this overlay back. And it seems like I might, because I'm looking at this triangle. I'm seeing a 2 mark and a 3 mark. I'm also thinking about this counterpart, which would be the XYZ. I'm seeing a 3 mark and a 2 mark as well. It takes some algebra, but I could certainly prove that side length in both triangles are congruent. Side angle side is an actual real possibility. So I'm going to put a little happy face there. Now I'm not going to commit to it yet because I want to make sure I don't have anything else. Angle side angle which would really demand that I know this angle here. Angle side angle. So do I know that one? I'm looking at this and I don't think I do. I have part of the angle, I don't have the other part. You could reason, it seems logical those are the same, but until you can actually have a theorem or something to quote that tells us that, well, it's just not going to be viable for us. Okay? So let's take that away. So angle side angle, again, probably not going to be a viable option for us. For the same reason, angle angle side is probably not going to be either. If you pull this overlay back, angle angle side would demand us know this angle. Well, again, that was the issue with angle side angle, is I don't know the other parts of this. I don't know enough about this diagram to be able to conclude perfectly that these angles are the same, unless you guys have a theorem that we have not talked about in class. So it seems our only recourse is going to be angle side angle. So we have one of those sides, we have the angle, we just actually have to prove this side is congruent. It's going to take some algebra, we can totally do it. So let's get into that. Let me clean this up. Let me take an opportunity to please clean this up. Okay. Now here's where a lot of people are going to make a mistake right off the bat. They're going to say a lot of this information that's given, and we got to be careful because the only thing we're actually given is that these two triangles are congruent. That generates a lot of information for us, but it's not given information. It's generated because the triangles are congruent, and that's something I want you guys to take careful note of. So let's make sure we have a plan kind of set. We're going to establish our congruent triangles. We're going to use that information to get a whole lot more information about diagrams, and we're ultimately going to prove these two triangles are congruent by side angle side. Okay, so let's do it. So our first step is to kind of get information into our diagram, into our proof. So if we know that triangle ZWV is congruent to triangle YXV, because it's given, I know that this generates a whole lot of information for us. We know that, and again, we got to kind of be careful here because I kind of mark my diagram differently. Okay, but this does tell us that angle 1 is congruent to angle 2. ZW is congruent to XY. And then WV congruent to VX. And ZV congruent to VY. Okay, now this is going to be because of the definition of congruent triangles. Now you'll notice I didn't put all the information that I had marked in my diagram into my proof. That's because a lot of it's unneeded. I actually just need the side length, I need the angle, and I need enough information to prove the second side length. In fact, I'm going to take this one step farther now because I'm kind of thinking ahead that to prove that WY is congruent to ZX is going to take a lot of algebra. Algebra is from equations, equations use measurements. So I want to take an opportunity to kind of think about these middle pieces not as congruencies but as measurements. So I'm going to take these last two statements that were congruencies and kind of convert them to measurements. That might be useful later on. In fact, I know it's going to be useful later on when I'm trying to actually prove these pieces, which is why I was kind of thinking, let's go ahead and establish it now. So here's where we'll now actually write the main body of our proof. We'll try to actually prove these two triangles are congruent. We established SAS was going to be our choice. So let's get into it. We have ZW congruent to XY, which will be our end pieces. Now the justification here is not given because we are not told that. We're told triangles are congruent and we generated from that. So our justification would actually be definition of congruent triangles. Definition being that all corresponding parts of congruent triangles are congruent. CPCTC. I don't personally like that, but that's what that abbreviation means. The angle in question would be angle 1 and angle 2. And again, we'd have to quote definition of congruent triangles, or corresponding parts of congruent triangles are congruent. And of course, then we have our last side, and this is going to be the bear. We kind of talked through this in the plan before, so again, rewind if you need to hear that argument again. But we need to show WY is congruent to ZX, and we can't do it directly. We have them in pieces that are congruent, and certainly since the pieces are congruent, they should be as well. But that's a piece of logic and thinking that we can't write into a flow proof. We could have written like a paragraph proof, that'd make more sense. But a flow proof, we can only provide the algebraic steps, not the logic behind the algebraic steps, which is why this has to be done very carefully. We're going to have to establish a relationship, show algebraically that relationship developing into a congruency. Here's what I mean. We can't state a direct congruency, but we can state that WV measurement plus a VY measurement should be equal to the WY measurement. In other words, two small segments add up to a bigger segment. In the same way that we can claim that XV plus VZ is equal to XZ. So again, two smaller segments adding up to be the entire segment. Both of these are justified the same way. Segment addition postulate, SAP. So now our goal is to show that the entire pieces are congruent, so we really have to show their calculations are congruent. They don't look the same now, so we actually have to do some modification to this. We have to make them, in other words, look exactly the same, but we established the pieces were the same in a very previous step. So we can do some direct substitution. In other words, we can directly say now that WV plus VY is the same as WY. Taking out XV, well, that should be VX. Taking out VX, we replace it with WV, so we shall. So instead of this piece, we shall write it as a WV, and that's because of this statement. We have a VZ, but we'll trade out a VZ for a VY. So again, we're substituting out this piece for the VY. And that's because, again, because substitution. And now we're looking at these two pieces. They are indeed going to be congruent. Or I should say congruent. Now they look exactly the same, which means the result should be exactly the same as well. And that can be because of substitution or transition. They're indistinguishable in this way. And if those pieces are indeed equal, that means the line segments themselves have to be congruent, because that's the definition of congruency. That's what it means to be congruent. So we have condition side, we have condition angle, and condition side. So since all three of these pieces are indeed true, I know that triangle ZWY is congruent to triangle YXZ. And that's because of the side angle side triangle congruency theorem. Okay, so again, I hope this helped. Thank you for watching this. Thank you for working hard and preparing yourself for this test we have upcoming on Monday. You know, spread the word. If you have some friends who you think you're going to slack off, this is a big test. It's worth a lot of points. They shouldn't be slacking off. You know, if you have comments, please post them at Moto. I'll be watching all weekend. So thank you. Thank you for working hard. Good luck.